This is a video abstract for the paper titled HST Wide-Field Camera 3 Complete Phase Resolve Spectroscopy of White Dwarf Brown Dwarf Binaries WD0137 and EPIC 2122. In this work, we use time-resolved spectra taken by the Hubble Space Telescope Wide-Field Camera 3 G141 grism to explore the circulation models, thermal profiles, and day-night temperature contrast of two brown dwarf companions that closely orbit their respective white dwarf hosts. Tidally-locked on orbits with periods less than 2 hours, these two brown dwarfs rotate faster than Jupiter and Saturn. They receive enormous stellar radiation that is comparable to that received by ultra-hot Jupiters. These characteristics place our targets in the intersection of being rotationally dominated, high temperature, and high gravity, a peculiar parameter space for studying atmospheric dynamics. Using HST time-resolved spectroscopic observations, we obtain the complete phase-resolved spectra of the two binaries. Both demonstrate greater than 10% brightness modulations. The large amplitudes imply extreme day-night contrast in these atmospheres. To fit the band-integrated phase curves requires at least second-order Fourier series models. Using the spherical harmonics-based story models, we can reproduce the high-order Fourier terms by introducing an isothermal hotspot centered at each brown dwarf substellar point. We also found that the phase curve shape agrees well with predictions from general circulation model simulations and models assuming radiative convective equilibrium. In these models, day-night heat transfer is severely impeded by the strong Coriolis force resulting from the brown dwarf's fast rotation rates. The inefficient energy transportation leads to the formation of hotspot at the substellar points. We remove the nearly featureless white dwarf spectra to derive the phase-resolved brown dwarf spectra. For both brown dwarfs, their entire spectral sequence are accurately represented by the linear combinations of their respective day and night side spectra. This allows us to focus our spectroscopic analysis on the day and night side alone. The day side spectra of both brown dwarfs are very well explained by the irradiated atmospheric models that carefully incorporate the effect of the white dwarf's intense ultraviolet irradiation. In contrast to the blackbody or non-irradiated models that do not fit observed spectra well, accurate representations of the opacity sources and the thermal profiles in the irradiated models are crucial for the good fit. In the night side, the spectrum of the cooler brown dwarf WD0137b shows a strong water absorption feature and matches the non-irradiated 1000K brown dwarf model. EPIC 2122b's night side emission is marginally detected and well fit by a 1300K Planck function. The brown dwarf spectra also reveals the remarkable wavelength dependence of the temperature contrast between the day and night sides, arguing for specifying the spectral band in cross comparison of the day-night contrast between different irradiated atmospheres. On the color magnitude diagram, brown dwarf WD0137b's day-to-night track directly connects the early L and mid-T type regions. This track differs from the one established by field brown dwarf observations that undergoes the LT transition, but agrees better with the cloudless brown dwarf models. Therefore, mechanisms such as cloud formation and disequilibrium chemistry that drive the substellar color magnitude evolution do not play a critical role in the day-night cycles of the highly irradiated atmosphere of WD0137b. Our work demonstrates remarkable opportunities that the white dwarf brown dwarf binaries put forward in studying substellar atmospheric dynamics. The high-quality phase-resolved spectra call for new models that couple atmospheric circulation and radiative transfer under high irradiation conditions for complete interpretation.